What if living past 70 was no longer just a matter of chance or good genes but something shaped by science and innovation, led by one of the boldest minds of our time? Imagine waking up one day to discover that everything you thought you knew about aging was about to be rewritten. Elon Musk, a man known for pushing humanity toward the future with rockets and electric cars, has recently made 7 shocking predictions about how we might live far beyond 70, and live better, longer, and healthier. But what if these predictions aren't just dreams? What if they're grounded in real science that's about to change your life? In a world obsessed with youth and vitality, the idea of outliving your 70th birthday with your mind sharp and body strong feels like science fiction. Yet Musk insists the future isn't as far away as we think. His visions challenge everything from how our brains work to how we fuel our bodies and even where we call home. But before diving into those predictions, pause and consider your own journey. What's one thing that always pushes you forward, even when things get tough? Is it love? A sense of purpose? Or maybe just the stubborn hope that there's more to life ahead? Hit subscribe and leave a comment with where you're watching from. This story might just spark a new beginning. Aging has always been one of humanity's greatest mysteries and fears. For decades, science has made small strides in understanding how we grow old, but none have offered a real roadmap to living well beyond 70 with vitality. Elon Musk's predictions shake this status quo. He's not just thinking about adding years but about fundamentally changing what those years look like. His vision draws on advances in technology, artificial intelligence, space travel, genetics, and even economic policies. But why is Musk so invested in this? To understand his passion for life extension, we have to look back at his own life story, marked by struggle, relentless ambition, and a desire to change the world. His childhood in South Africa was filled with hardship, bullying, and a hunger for knowledge that made him devour books on physics, computers, and science fiction. These early experiences forged a mind that refused to accept limits. Musk's ventures, PayPal, Tesla, SpaceX, Neuralink, may seem like separate worlds, but they're united by a single thread, solving problems that threaten humanity's future, including the inevitability of aging and death. The predictions he makes aren't just hopeful ideas, they're rooted in his company's cutting-edge work in scientific research. Imagine a future where your brain connects directly to computers, helping you preserve memories and stay mentally sharp well into old age. Picture Mars colonies where humans escape the planet's environmental limits, opening new frontiers for life extension. Think about diets powered by lab-grown meat that could reduce diseases linked to poor nutrition. These are not far-off fantasies but active projects already underway. Yet with great innovation comes deep controversy and fear. Many wonder if such changes will rob us of what makes us human. Others question the ethical boundaries of genetic engineering and artificial intelligence. Some worry about the societal divides that could grow if longevity becomes a luxury only for the rich. Musk himself faces criticism and doubt, but his resolve remains firm, driven by a vision bigger than any one person. As this story unfolds, you'll witness how each prediction ties into a broader human struggle, our fight against time, disease, and the limits imposed on us by biology and circumstance. You'll meet people whose lives have been touched by these innovations, both positively and painfully. You'll explore the conflicts, setbacks, and moments of hope that mark this journey toward redefining what it means to grow old. So what does it really mean to live past 70 in the world Musk imagines? Is it a blessing, a curse, or something more complex? This story is about more than just science and technology, it's about love, sacrifice, fear, and hope. It's about how each of us faces the ticking clock in our own way and how the future might hold unexpected gifts for those willing to embrace change. What if your next birthday wasn't a reminder of loss, but a celebration of possibility? What if the struggles you've faced prepared you for a new chapter, one where aging doesn't define your limits but expands your horizons? This isn't just a story about Elon Musk or his predictions. It's a story about all of us. The future is coming faster than you think. Are you ready to meet it? Hit subscribe and leave a comment with where you're watching from. This story might just spark a new beginning. What's one thing that always pushes you forward, even when things get tough? Hit subscribe and leave a comment with where you're watching from. This story might just spark a new beginning. What's one thing that always pushes you forward, even when things get tough? To understand Elon Musk's bold predictions about living past 70, you need to understand the man himself, a visionary whose relentless drive has shaped the way we think about technology, the future, and even the limits of human life. Born in Pretoria, South Africa, Elon's childhood was marked by both brilliance and struggle. He was a curious and bookish boy, spending hours absorbed in books about physics, computers, and science fiction. Yet he also faced intense bullying at school and the isolation that comes from being different. These early years planted the seeds of his ambition, a desire not just to succeed, but to make a lasting impact on humanity's future. As a young man, Musk moved to Canada and then the United States, where he plunged into a career that seemed destined for disruption. His first success was Zip2, a company that provided online city guides, but it was PayPal that first made him a household name, revolutionizing how we think about money and transactions. But Musk's ambition stretched far beyond finance. He dreamed of reducing humanity's reliance on fossil fuels, colonizing Mars, and integrating human brains with computers. What ties these ventures together is his underlying obsession with survival and progress, especially as it relates to life's fragility. Behind Musk's predictions about longevity lies a personal narrative shaped by a fear of death, not just his own, but humanity's. The loss of loved ones and his own brush with life-threatening situations fueled a sense of urgency to find solutions that could push the boundaries of human life. Musk's family relationships have played a profound role in shaping his motivations. His mother, May Musk, is a model and dietitian who instilled in him a belief in resilience and pushing boundaries. His father, Errol Musk, was an engineer, a figure who inspired Elon's interest in machines and problem-solving, but their relationship was complicated, filled with conflict that pushed Elon toward independence. In his adult life, Musk has faced challenges that test his resolve daily, from failed rocket launches to financial near-bankruptcy, and the public scrutiny that comes with being a high-profile entrepreneur. Yet he often credits his family and close friends for giving him the strength to keep going. His 7 children are another source of motivation. Musk has spoken about wanting to leave the world in better shape for future generations. These personal connections humanize a man who might otherwise seem like a distant titan of industry. His predictions about longevity aren't just scientific curiosities, they're deeply personal aspirations. Musk's personality is a mix of contradictions. On one hand, he is a perfectionist with almost obsessive attention to detail. On the other, he's a risk-taker willing to bet everything on what others call impossible. He can be charming and inspiring but also stubborn and hard to work with. This complexity makes his story compelling and his predictions all the more fascinating. The emotional roller coaster of his life, successes followed by setbacks, moments of hope followed by crises, mirrors the narrative arc of his vision for the future. Musk's work ethic is legendary. Stories of his grueling schedule, sleeping at the factory, and pushing his teams beyond exhaustion are common. This dedication springs from a belief that the survival of humanity depends on breakthroughs that must happen now. Unlike many entrepreneurs, Musk doesn't see his work as just business. He frames it as a mission to solve existential threats, from climate change to the risk of extinction. This sense of purpose underpins his 7 shocking predictions about living past 70. Each prediction builds on a foundation of decades of work, combining technology with philosophy, ethics with pragmatism. To Musk, living longer and healthier isn't just about adding years to life, it's about adding life to years. It's about redefining what it means to age, to grow older not as a decline but as a new phase of potential. This vision is radical because it challenges the natural order. Aging has been accepted as inevitable for thousands of years. Musk, however, is betting on the idea that the limits we've accepted are human-made and that technology can break through those barriers. Yet, as with all visionaries, Musk's ideas are met with skepticism. Critics accuse him of overpromising and underdelivering. Some question whether his predictions are realistic or just hype designed to attract investment. Others worry about the societal implications. Who will have access to life-extending technologies? Will they deepen existing inequalities? Musk's response to these concerns is both pragmatic and idealistic. He acknowledges the risks and challenges but insists that humanity must move forward regardless. His companies reflect this mindset. Tesla aims to accelerate the world's transition to sustainable energy, SpaceX wants to make life multiplanetary to safeguard humanity, Neuralink seeks to merge humans with AI to avoid obsolescence. Each project contributes to his broader vision of extending human life and capability. The psychological backbone of Musk's predictions also lies in his relationship with failure. Unlike many who fear setbacks, Musk embraces them as essential to progress. His famous quote, "Failure is an option here. If things are not failing, you are not innovating enough," reveals a mindset that views the difficulties of pushing human limits as necessary trials on the way to breakthroughs. This attitude is crucial when considering his longevity predictions because extending life involves navigating uncharted scientific territory, high stakes and high uncertainty. Musk's story also intersects with popular culture and media narratives that oscillate between fascination and fear of aging. In America, where youth culture dominates, aging is often seen as decline or loss. Musk's ideas offer a different narrative, one where aging could be transformed into something aspirational, exciting, and full of new possibilities. This has the power to reshape how society views older adults, potentially reducing ageism and inspiring a new generation to embrace their later years with optimism. Understanding Musk's psychology helps explain why his predictions, though shocking, carry weight. They come from a place of deep personal conviction and a relentless desire to push humanity forward, not just technologically but morally and socially. His vision is not just about living longer but about evolving as a species. While Musk's life and personality form the foundation of his predictions, the real question is, how do these 7 shocking ideas translate into reality? What technologies, discoveries, and societal changes could actually make living past 70 not just possible but vibrant? Over the next chapters, we will explore each prediction in detail. From brain-machine interfaces to space colonization, from genetic engineering to economic reforms, all tied back to Musk's story and the scientific research backing these claims. Along the way, we'll meet people living on the edge of these technologies, facing both hope and fear. We'll examine the conflicts these innovations spark and the unexpected journeys they lead to. Musk's life story is the emotional thread weaving through this narrative, a reminder that behind every prediction is a human being wrestling with time, loss, and the desire to leave something lasting. As we peel back the layers of his vision, you'll see how his personal history informs his understanding of what it means to live a long life. His failures teach us about resilience. His successes show the power of dreaming big. And his relationships remind us that love and connection remain at the heart of any meaningful future. In the end, Musk's predictions aren't just about technology or science, they're about hope. Hope that we can rewrite the rules of aging. Hope that the struggles of the past can fuel breakthroughs in the future. Hope that living past 70 will be less about survival and more about thriving. So as we move forward into this story, keep in mind the complexity of the man behind the vision. His predictions are a reflection of his fears and dreams, his setbacks and victories. They challenge us not only to imagine a different future but to engage with the present in new ways. What will you do with this knowledge? How will it change your view of aging, life, and possibility? The journey ahead is not just Elon Musk's, it's ours. Together, we'll explore the science, the controversies, and the emotional highs and lows of a future where living past 70 is not a distant fantasy but an attainable reality. Stay curious, stay hopeful, and get ready to rethink everything you thought you knew about growing old. Elon Musk's first shocking prediction about living past 70 revolves around a technology that sounds straight out of science fiction but is rapidly becoming a reality: the integration of the human brain with machines. This is the promise behind Neuralink, Musk's brain-computer interface project, which aims to connect our minds directly to computers, potentially transforming how we think, remember, and even age. Imagine being able to preserve your memories, enhance your cognitive abilities, or slow down mental decline by uploading information directly to your brain or using AI-assisted neural pathways. For many, this sounds like a miraculous solution to one of the most feared aspects of aging, losing one's mind. Dementia, Alzheimer's, and other neurodegenerative diseases strip away the essence of who we are, turning vibrant individuals into shadows of their former selves. Musk's vision is to use technology to fight back against this cognitive decay, giving people the chance to live longer with their mental faculties intact. Neuralink's devices are tiny, flexible electrodes implanted in the brain that can read and write neural signals. Early experiments have shown promising results in helping paralyzed patients control computers or robotic limbs with their thoughts. While this technology is still in its infancy, Musk believes it will evolve rapidly and become a tool for everyone, not just those with disabilities. The idea is that by directly interfacing with our brains, we can monitor health indicators, detect early signs of disease, and even stimulate brain regions to maintain or improve cognitive function. This prediction challenges our traditional understanding of aging as a purely biological process confined to the body and brain's natural limits. It suggests that technology can intervene at a fundamental level, altering how our brains age and function. But this vision isn't without controversy and fear. Many people worry about privacy and identity. What happens when your thoughts can be accessed or altered by a machine? Will we lose what makes us human if our brains become partly artificial? Could such technology be hacked or misused? These questions fuel a rising conflict around mind-machine integration. Musk himself acknowledges the risks, often emphasizing that while AI and brain interfaces offer enormous benefits, they must be developed carefully and ethically. In the broader narrative of aging, this technology represents both hope and tension. On one hand, it offers a way to preserve the mind's sharpness, a critical factor in quality of life for older adults. On the other, it raises fears of dehumanization and loss of control. Stories from families dealing with dementia show the devastating emotional toll cognitive decline takes, not just on patients but on caregivers who watch their loved ones fade away. For these families, Musk's prediction offers a glimmer of hope that one day, technology could change the narrative from loss to preservation. Consider Jane, a 72-year-old retired teacher who watched her mother suffer from Alzheimer's for years. Jane's fear of developing the disease herself is constant, but the idea of a Neuralink-like device gives her hope that she might one day be able to keep her memories alive, her mind sharp, and her identity intact. This hope isn't just about medical science, it's about dignity and connection. Yet, despite the promise, there are technical and ethical hurdles to overcome. Implanting electrodes in the brain is invasive and risky, and the long-term effects are still unknown. Society must grapple with questions of consent, access, and regulation to ensure such technology benefits all, not just a privileged few. The tension between the incredible potential and the real dangers creates a dynamic narrative, one of progress shadowed by uncertainty. Musk's prediction here serves as a catalyst for broader discussions about the future of humanity and the boundaries of technology. Scientific research backs some of these ideas. Studies in neuroplasticity show that the brain can adapt and rewire itself, suggesting that artificial stimulation might slow cognitive decline. AI-driven diagnostics are already improving early detection of diseases like Alzheimer's. While the full integration Musk envisions is still a work in progress, the trajectory is clear: technology will play an increasingly central role in how we age mentally. This prediction fits into Musk's larger vision of enhancing human capability rather than just extending lifespan. It's not enough to live longer if the mind deteriorates. True longevity means maintaining the full spectrum of human experience, memory, creativity, emotion, and identity. As Neuralink advances, it challenges us to rethink what it means to be human. If our brains can interface seamlessly with machines, are we still ourselves? What new possibilities and risks does this open? The emotional dimension of this prediction is profound. The fear of losing one's mind is one of the deepest human fears. Musk's vision offers a way to confront that fear directly, giving hope that aging doesn't have to mean decline but can be met with tools that preserve who we are. Yet this hope comes with the need for vigilance, wisdom, and a commitment to ethical innovation. For now, Neuralink remains a pioneering project, one that symbolizes both the promise and peril of the future Musk predicts. It is a first step toward a new kind of aging, one where mind and machine work together to extend life's possibilities. As the story continues, we will see how this prediction intersects with others, how space travel, genetic engineering, AI, and more combine in Musk's vision to redefine what it means to live past 70. But before moving on, pause and imagine this future, a world where your brain never forgets, where your thoughts can travel faster than ever, where aging is not a sentence but a challenge met with cutting-edge technology. What would you do with such power? How would it change your life and relationships? The first prediction is both a promise and a question, one that will shape the journey ahead. Elon Musk's second shocking prediction about living past 70 takes us far beyond Earth, into the realm of space colonization. While most of us think of space travel as an adventurous dream or a scientific frontier, Musk envisions it as a fundamental part of humanity's survival strategy, and a radical way to extend human life. According to Musk, establishing self-sustaining colonies on Mars and beyond is not just about exploration, it's about escaping Earth's biological and environmental limits that contribute to aging and mortality. Our planet, despite its beauty, is a place filled with risks, from climate change and pandemics to resource depletion and natural disasters. Musk argues that relying solely on Earth is a gamble on our species' future. Creating space colonies means creating new environments where humans could thrive differently, potentially free from some of the aging factors that plague us here. But how exactly could living in space help people live longer? The key lies in rethinking what causes aging in the first place. On Earth, aging is influenced by countless factors. Exposure to pollutants, gravity's effect on our bodies, disease vectors, and even the psychological stress of living in crowded or damaged environments. Musk suggests that off-world colonies could offer cleaner atmospheres, controlled environments, and advanced medical technologies integrated into daily life, reducing many aging accelerators. The idea of space colonies for longevity also ties into the concept of starting fresh, designing new societies from the ground up with longevity and health at their core. Imagine habitats built with cutting-edge life support systems, optimized nutrition, and constant health monitoring, all powered by renewable energy and AI. In these colonies, the old limitations of Earth-bound aging might be overcome by technology and innovation. Yet, the journey to making space colonies a reality is fraught with challenges. The harsh environment of Mars, for example, with its low gravity, radiation exposure, and thin atmosphere, poses serious threats to human health. Musk and his teams at SpaceX are working tirelessly to develop technologies to shield settlers from radiation and simulate Earth-like gravity, possibly through rotating habitats. These solutions are not merely technical, they are lifelines to enable long-term survival and health in space. Another major obstacle is the psychological toll of isolation and confinement in space colonies. Long-term space travel and settlement will require addressing mental health with as much rigor as physical health. Musk envisions AI companions, virtual reality, and social structures designed to keep settlers connected and emotionally supported. This integration of technology and human psychology is essential for any hope of thriving past 70 in such environments. The vision of space colonization as a longevity strategy sparks tension and debate. Some critics call it escapism, arguing we should focus on fixing Earth's problems instead of fleeing to other planets. Others question the feasibility and ethics of sending humans to harsh and untested environments. Musk responds by saying that space colonization is part of a diversified survival plan, our insurance policy, against extinction-level events on Earth. This prediction, therefore, combines hope and urgency, hope in the potential of human ingenuity to create new worlds, and urgency born from real threats facing our planet. It also touches on the profound human need to explore, adapt, and survive. Stories from early astronauts and researchers offer a glimpse into this future. Their experiences highlight both the marvel and hardship of living beyond Earth. Physical challenges like muscle atrophy and bone loss in microgravity are well documented, but these same challenges drive innovation in exercise technologies, pharmaceuticals, and nutrition, tools that could also benefit aging populations on Earth. Think about the parallels. If we can solve these problems for space settlers, we can apply those solutions to aging adults here, improving mobility, strength, and resilience. Furthermore, the vision of space colonies challenges our sense of identity and belonging. What does it mean to be human when our species is scattered across planets? How will culture, family, and community evolve in these new settings? Musk believes that colonization will spark new social models, creating opportunities to rethink aging not as decline but as an active, adaptive process supported by community and technology. The economics of space colonization also come into play. Musk's SpaceX is aggressively working to lower the cost of launching rockets, aiming to make travel to Mars affordable enough to support large populations. The ultimate goal is not just a handful of astronauts living off-world but entire generations thriving in space habitats designed for health and longevity. This aligns with Musk's broader idea of a multiplanetary future where humanity's survival isn't tied to one fragile planet. Scientific research supports some of these concepts. Studies on radiation exposure help design better shielding materials, while biomedical research explores how low gravity affects aging at the cellular level. Emerging fields like astrobiology and space medicine work to understand how life can be sustained and enhanced beyond Earth. Musk's prediction pushes these fields into new territory, focusing on longevity as a key goal of space colonization. Emotionally, the idea of leaving Earth behind can evoke a mixture of excitement, fear, and nostalgia. For many, Earth is home, tied to memories, culture, and identity. The thought of spending decades or an entire lifetime on another planet challenges deep human attachments. Musk's vision asks us to expand our horizons and consider a future where home is no longer just one place but many, where life's meaning evolves with new environments. As we explore this prediction, it's clear that space colonization is more than a technological challenge, it's a profound human experiment. It forces us to reconsider how environment shapes aging, health, and community. It offers a dramatic and hopeful way to extend human life, not by fighting time alone but by transforming the conditions of life itself. So, imagine waking up on Mars, breathing air filtered through advanced systems, living in a habitat designed to keep your body strong and your mind engaged. Imagine a world where the threat of aging diseases is reduced by cutting-edge medical tech integrated into daily life, where your community spans stars rather than cities. This is the bold future Musk predicts, a future where living past 70 is not only possible but part of a new chapter in human evolution. But with this vision comes questions: would you leave Earth behind to extend your life? What would it mean to build a new family and community light years away? How would this shape your understanding of time, aging, and legacy? Musk's space colony prediction pushes us to confront these questions and imagine possibilities once thought impossible. It is a testament to human resilience and creativity, a reminder that our future is not predetermined but something we can shape with boldness and vision. As we move forward, we'll see how this prediction interlocks with Musk's other ideas, from mind-machine integration to genetics, from AI to social reform, all weaving together into a complex, hopeful tapestry about living longer, better, and fuller lives. This chapter ends with the image of humanity looking up at the stars not just with wonder but with practical hope, hope that beyond those distant lights lies a new frontier for life itself. Elon Musk's third shocking prediction about living past 70 dives deep into the very blueprint of life, our genes. Musk believes that genetic engineering will become one of the most powerful tools to fight aging and dramatically extend human lifespan. Unlike traditional medicine, which treats symptoms or diseases after they occur, genetic engineering aims to rewrite the underlying code that drives aging itself. This prediction is grounded in the rapidly advancing field of biotechnology, where scientists are beginning to understand how certain genes regulate cellular aging, repair, and death. By editing these genes, it could be possible to slow, halt, or even reverse the biological processes that cause aging. Musk's interest in this area aligns with his broader vision of harnessing technology to overcome natural limits. Genetic engineering could fundamentally alter what it means to grow old, making 70 just the beginning of a long, healthy life rather than a milestone near the end. The science behind this is complex but fascinating. Aging at the cellular level involves the gradual accumulation of damage to DNA, proteins, and cell structures. Telomeres, the protective caps at the ends of chromosomes, shorten with each cell division, eventually leading to cell death or malfunction. Other mechanisms include oxidative stress, inflammation, and genetic mutations that accumulate over time. Researchers have identified specific genes linked to longevity and healthspan in various organisms, from worms to mice, and are exploring ways to modify these genes in humans. Musk's prediction suggests that advances like CRISPR gene editing technology will soon enable precise interventions to enhance these protective mechanisms, effectively reprogramming cells to stay youthful and functional much longer. But genetic engineering for longevity raises profound ethical and societal questions. What does it mean to alter human DNA at such a fundamental level? Who will have access to these technologies? Could it lead to unintended consequences, such as new diseases or genetic inequalities? Critics warn of designer babies, and a future where only the wealthy can afford genetic enhancements, widening the gap between rich and poor. Musk, however, envisions a future where these technologies become affordable and accessible, integrated into healthcare systems worldwide to benefit all of humanity. He emphasizes the importance of regulation and ethical frameworks to guide responsible development. The tension here is palpable. The promise of defeating aging through genetics versus the risks of playing God with the human genome. Stories of people with genetic diseases offer both hope and caution. For instance, therapies that edit faulty genes to cure inherited conditions are already showing success. Extending these techniques to target aging is a natural but more complex step. Consider Mary, a 68-year-old woman with a family history of heart disease and dementia. The idea of genetic engineering offers her hope, not just to treat disease but to avoid it altogether, living a longer, healthier life with the vitality of youth. This personal angle brings the science closer to home, highlighting the profound impact such technology could have on millions of people. Scientifically, the progress is accelerating. Clinical trials involving gene therapies targeting age-related diseases are underway. Researchers are exploring ways to lengthen telomeres, reduce cellular senescence, the state where cells stop dividing and accumulate, and enhance DNA repair mechanisms. These approaches aim not only to extend lifespan but also to improve healthspan, the period of life spent in good health. Musk's prediction highlights the transformative potential of combining genetic engineering with other technologies, like AI and personalized medicine, to create tailored interventions for individuals based on their genetic makeup. This could revolutionize how aging is managed, shifting from reactive treatments to proactive prevention and repair. The emotional dimension of this prediction is profound. Aging carries with it fears of decline, dependency, and loss of identity. Genetic engineering offers the possibility of reclaiming control over these processes, turning aging into a manageable condition rather than an unavoidable fate. But it also forces us to confront deep philosophical questions about what it means to be human. If we alter our genetic code to live longer and healthier, do we change our essence? How will extended lifespans affect family, work, and society? The social implications are vast. Longer lives could mean extended careers, delayed retirement, and new forms of intergenerational relationships. It could also raise challenges in resource distribution, population growth, and social services. Musk's vision is not naive. He recognizes these complexities and calls for a holistic approach that includes policy, ethics, and education alongside technological innovation. This prediction connects with Musk's other ideas, such as mind-machine interfaces and space colonization, in creating a multifaceted approach to longevity. Genetic engineering is the biological foundation, neural interfaces enhance mental capacity, and space colonies provide new environments, together forming a comprehensive strategy to extend life beyond current limits. As we imagine this future, picture a world where genetic tests are routine, and gene therapies are common practice to keep cells young and bodies strong. Imagine personalized treatments that adapt as you age, preventing diseases before they start and repairing damage as it occurs. This is the world Musk foresees, a world where living past 70 is not just possible but expected. However, the path to this future requires careful navigation. Scientists must balance innovation with caution, ensuring safety and addressing ethical concerns. Society must prepare for the profound changes extended longevity will bring, from healthcare systems to cultural attitudes about aging and death. Musk's prediction is both a call to action and a vision of hope. It challenges us to rethink aging not as an inevitable decline but as a complex biological process that we can influence and control. It invites us to embrace the possibility of rewriting the story of human life, with genetics as the key. As you consider this prediction, ask yourself, what would a longer, healthier life mean to you? How would it change your goals, relationships, and sense of purpose? Are we ready as a society to handle the ethical and social challenges that come with this power? Musk's genetic engineering prediction is a bold leap into the future, a vision where science and humanity meet to rewrite the rules of aging. It sets the stage for the next steps in this journey, a journey filled with promise, risk, and the enduring human desire to live fully and long. Elon Musk's fourth shocking prediction about living past 70 focuses on the incredible potential of artificial intelligence to transform medicine into a highly personalized and proactive science. Traditional medicine often operates on a reactive model, waiting for symptoms or diseases to manifest before intervening. Musk envisions a future where AI continuously monitors individual health data, predicts risks, and tailors treatments specifically designed for each person's unique biology. This approach, known as personalized medicine, has been on the horizon for years, but Musk believes AI will accelerate its arrival and effectiveness to unprecedented levels. The concept is simple yet profound. No two people age exactly the same way, so why should their healthcare be the same? AI algorithms can analyze vast amounts of genetic, metabolic, lifestyle, and environmental data to understand how each individual's body changes over time. This continuous, real-time insight allows for early detection of disease, optimization of treatments, and even preventative measures that keep people healthier longer. For example, an AI system might detect subtle biochemical changes in the blood years before symptoms of cancer or Alzheimer's appear, enabling early intervention that could save lives. Or it might recommend lifestyle adjustments tailored to your specific genetics and habits to prevent chronic conditions like diabetes or heart disease. Musk's prediction hinges on AI's ability to process data far beyond human capacity and to learn and adapt continuously. This makes healthcare dynamic and personalized, rather than static and one-size-fits-all. The technology relies on wearable sensors, advanced diagnostics, and cloud computing to collect and analyze data. Already, devices like smartwatches can track heart rate, sleep patterns, and activity levels. Future iterations, combined with AI, will integrate blood tests, microbiome analysis, and even brainwave monitoring. This flood of information will empower individuals and doctors with detailed, actionable insights. Yet this vision raises critical questions about privacy, data security, and the potential for AI errors. Who owns this personal health data? How do we prevent misuse or discrimination based on genetic risk factors? Musk stresses the importance of robust safeguards and transparent AI systems to ensure trust and ethical use. The tension between technological promise and privacy concerns fuels ongoing debates in healthcare and policy. Personal stories help illustrate the impact of AI-driven personalized medicine. Take Tom, a 75-year-old retired engineer who uses an AI-powered health platform that continuously monitors his vital signs and medication effectiveness. Thanks to early detection and personalized treatment plans, Tom has avoided major health crises common in his age group, maintaining his independence and quality of life. His story shows how AI can turn aging from a decline into an actively managed process. Scientific research backs this up. Studies have demonstrated AI's superiority in diagnosing diseases such as skin cancer and diabetic retinopathy compared to traditional methods. Moreover, AI is being used to identify new drug candidates and optimize dosing for complex diseases. This technology can also uncover previously unknown connections between genes, environment, and disease risk, offering new avenues for treatment. The emotional impact of this prediction is significant. Aging often brings fear of losing control over one's health and becoming dependent. AI-driven personalized medicine offers a counter-narrative, one of empowerment and hope. Knowing that your health is being continuously monitored and managed by intelligent systems can reduce anxiety and promote proactive engagement with wellness. But it also requires a cultural shift. People will need to become comfortable with sharing detailed personal data and trusting AI-guided decisions, which may differ from traditional medical advice. This shift highlights the need for education and transparent communication to build confidence in these new systems. Economically, AI-driven personalized medicine promises to reduce healthcare costs by preventing expensive hospitalizations and treatments through early intervention. It could also optimize resource allocation by targeting therapies to those most likely to benefit, reducing waste. Musk envisions healthcare systems transformed by AI, becoming more efficient and accessible, especially as wearable and diagnostic technologies become affordable and widespread. This aligns with his broader vision of using technology to improve quality of life and democratize access to cutting-edge care. AI's role in combating aging is not just about technology but about reshaping the human experience of growing older. With real-time data and adaptive treatment, aging could become less about decline and more about continuous adjustment and improvement. This means more active years, less disability, and the possibility of maintaining independence far beyond 70. Musk's prediction also intersects with his other ideas. AI-powered health monitoring complements genetic engineering by identifying who would benefit most from gene therapies and when. It works hand in hand with mind-machine interfaces to track cognitive health and mental wellness. And it supports the space colonization vision by providing settlers in harsh environments with immediate, intelligent healthcare support. Picture a future where AI assistants are part of your daily life, analyzing your health data, suggesting personalized diets, exercise routines, and mental health practices. Imagine receiving alerts for early signs of disease, with tailored treatment plans delivered remotely by telemedicine specialists. This is the future Musk describes, a future where aging is managed proactively and individually. However, this future also poses ethical dilemmas. Will AI systems be unbiased and fair? How will healthcare providers adapt to these new tools? Will insurance systems change to accommodate personalized risk profiles? Musk emphasizes collaboration between technologists, healthcare professionals, ethicists, and policymakers to ensure AI benefits all, not just a privileged few. As we reflect on this prediction, consider your own experience with healthcare. How might AI change the way you interact with doctors and manage your health? Would you trust an AI system with your most personal data if it promised to keep you healthier longer? This chapter's exploration of AI-driven personalized medicine reveals a powerful tool in Musk's vision for living past 70, a tool that turns aging from a passive process into an active, managed journey. It offers hope, challenge, and a glimpse of a future where technology and humanity converge to rewrite the rules of longevity. The journey continues, weaving together with Musk's other predictions to create a comprehensive, technologically empowered roadmap for life beyond the current limits. Elon Musk's fifth shocking prediction about living past 70 centers on the brain, the most complex organ in the human body and the key to our identity, memory, and cognitive function. As we age, cognitive decline becomes one of the most feared and debilitating aspects of growing older. Musk envisions a future where advanced neural interfaces, devices that connect directly to the brain, will preserve and even enhance cognitive abilities, allowing people to maintain mental sharpness well beyond their 70s. Neural interfaces, sometimes called brain-computer interfaces, BCIs, are rapidly evolving technologies that bridge biological neural networks and computers. Musk's company Neuralink is at the forefront of this field, developing implantable devices that can record brain activity, stimulate neurons, and facilitate communication between the brain and external machines. This technology has the potential not only to treat neurological disorders like Parkinson's disease and paralysis but also to augment human cognition. The idea that neural interfaces can preserve cognitive function with age is revolutionary. Normal aging leads to memory lapses, slower processing speed, and diminished executive function, impacting quality of life and independence. Conditions such as Alzheimer's and dementia exacerbate this decline. Musk predicts that neural interfaces will offer a direct method to monitor, maintain, and improve brain health by detecting early signs of deterioration and providing targeted stimulation or repair at the neural level. This prediction is grounded in exciting scientific developments. Studies show that electrical stimulation of certain brain areas can improve memory and cognitive performance. Neural interfaces can also gather detailed brain data over time, enabling personalized interventions to maintain neural plasticity. The brain's ability to adapt and reorganize itself, which diminishes with age. Furthermore, neural interfaces could enhance cognitive function beyond baseline by enabling seamless access to digital information, improved learning speeds, and new ways to communicate and create. Imagine being able to recall information instantly or learn new skills at unprecedented rates, powered by a direct brain-computer link. Musk's vision here is not just about combating decline but about transcending current cognitive limits. This brings up profound ethical and social questions. What does it mean for personal identity if our thoughts and memories can be accessed, enhanced, or even altered by machines? Who controls this technology, and how is privacy maintained in a world where brain activity could be recorded? Critics warn about risks of hacking, misuse, and social inequality if cognitive enhancement becomes available only to the wealthy. Musk advocates for transparent development, strict ethical guidelines, and democratization of access to ensure these powerful tools benefit society as a whole. The emotional dimension of this prediction is significant. Many fear losing their mental faculties more than physical decline, as cognition is central to selfhood. The promise of neural interfaces offers hope to millions facing the prospect of dementia or other cognitive disorders. Stories of patients with neural implants regaining lost functions inspire optimism, illustrating the life-changing potential of these technologies. At the same time, there is a psychological adjustment to the idea of integrating machines with our brains, a blending of biology and technology that challenges traditional concepts of the mind. Neural interfaces could also reshape social interactions. With enhanced cognitive and communicative abilities, people might connect in new ways, sharing thoughts or emotions directly. This could foster deeper empathy and understanding or, conversely, create new forms of alienation depending on access and use. The technology might also influence creativity, enabling artists, musicians, and writers to harness AI-enhanced cognitive tools, pushing the boundaries of human expression. Economically, neural interfaces could transform industries by extending working lifespans and productivity. Older adults might maintain mental acuity needed for complex tasks, delaying retirement and contributing to society longer. This aligns with Musk's broader vision of reimagining aging as a phase of growth and opportunity rather than decline. However, this raises policy and workforce questions about adapting jobs, education, and social services for extended cognitive longevity. Musk's prediction intersects with his other longevity ideas. For example, neural interfaces could work with AI-driven personalized medicine to monitor brain health continuously and deliver precise neurostimulation treatments. They could also enhance communication for space colonists, where mental resilience and rapid information processing are critical. As you envision this future, imagine waking up with a neural implant that alerts you to early signs of cognitive fatigue, suggests brain exercises, or instantly retrieves needed information without lifting a finger. Imagine enhanced creativity, sharper memory, and seamless connection to digital networks integrated with your thoughts. This is the transformative promise Musk predicts, a future where cognitive decline is no longer inevitable but managed and even reversed through technology. Yet, embracing this future requires society to grapple with new definitions of humanity, privacy, and ethics. It challenges us to rethink what it means to be ourselves in an age where mind and machine merge. As you reflect on this prediction, consider your own cognitive health. What would it mean to maintain or enhance your mental abilities past 70? How comfortable would you be with neural devices connected to your brain? What safeguards would you want in place? Musk's neural interface prediction is both hopeful and challenging, pushing the boundaries of science and philosophy. It offers a glimpse of a future where living past 70 includes not just physical health but mental vitality and expansion, where age does not limit the mind but frees it through technology. This chapter adds a vital layer to Musk's longevity vision, integrating brain health with genetic, AI, and environmental strategies to create a comprehensive approach to extending life and quality of life. As the story unfolds, this prediction invites us to imagine a future where aging is no longer feared but embraced as an opportunity for continued growth, creativity, and connection, powered by the fusion of human and machine. Elon Musk's sixth prediction about living past 70 stretches beyond Earth's boundaries and into the cosmos. Musk believes that the future of human longevity is deeply connected to the colonization of space. This may sound like science fiction, but Musk argues that expanding humanity's reach beyond our planet is not only about exploration or survival but also about improving the quality and length of human life. The rationale behind this prediction is multifaceted. First, Earth's environment is subject to natural disasters, resource depletion, and pollution, all of which affect human health and lifespan. Musk envisions space colonies as havens where humans can live in carefully controlled, optimized environments free from many of Earth's health hazards. Second, space colonization will drive technological innovations that directly benefit human longevity. The challenges of living on Mars or the Moon, such as radiation exposure, limited resources, and low gravity, will push scientists and engineers to develop advanced life support systems, medical technologies, and environmental controls. These technologies will likely translate into better healthcare and living conditions back on Earth, helping people live longer, healthier lives. Third, Musk argues that spreading humanity across multiple planets is a hedge against existential risks, catastrophic events like asteroid impacts or nuclear war that could threaten life on Earth. By becoming a multiplanetary species, humans ensure the survival and continuity of civilization, preserving knowledge and genetic diversity for future generations. This prediction aligns with Musk's personal mission with SpaceX, to build sustainable colonies on Mars and beyond. Space colonization will require self-sufficient ecosystems that recycle air, water, and nutrients, creating closed-loop environments that mimic and improve on Earth's systems. These habitats could offer unparalleled health benefits, such as clean air, radiation shielding, and controlled diets tailored for longevity. The scientific challenges of space colonization are immense. Mars, for instance, has a thin atmosphere, extreme temperatures, and high radiation levels. Humans living there will face muscle and bone loss due to low gravity, psychological stresses from isolation, and the need for constant resupply and maintenance. Musk predicts that overcoming these challenges will catalyze breakthroughs in medicine, biotechnology, and environmental engineering that will benefit aging populations on Earth. Imagine a future where astronauts and colonists live with real-time health monitoring and regenerative therapies developed to combat space-specific aging effects. These treatments could then be adapted for terrestrial use, extending healthy lifespans worldwide. The emotional impact of this prediction is profound. Space has always symbolized hope, adventure, and the human spirit's boundless curiosity. For many, the idea of living on another planet conjures images of new beginnings, second chances, and the ultimate escape from earthly limitations. Musk taps into this deep-seated yearning for transcendence, suggesting that our future longevity depends not only on medical and technological advances but also on expanding our horizons literally beyond the stars. Yet, this vision also evokes fear and uncertainty. Space colonization raises ethical dilemmas about planetary protection, the treatment of extraterrestrial environments, and the social dynamics of off-world communities. What rights and responsibilities will colonists have? How will societies govern themselves millions of miles from Earth? Will access to space colonies be equitable or limited to the elite? Musk acknowledges these challenges and calls for careful planning, international cooperation, and inclusive policies to ensure that space colonization benefits all humanity. Personal stories of astronauts and researchers working on space medicine provide a human face to this prediction. Many describe the physical and psychological tolls of space travel, but also the remarkable adaptations and innovations born from necessity. These experiences demonstrate humanity's resilience and the potential for space technology to transform life on Earth. Economically, space colonization could open new industries and jobs, driving growth and innovation. Musk sees it as a catalyst for a new era of prosperity, where resources mined from asteroids and other planets support Earth's economy and human health. This economic dimension complements the longevity focus by creating sustainable systems that support extended life. The social implications of this prediction are vast. Living in space colonies will require rethinking community, identity, and human relationships. Extended lifespans might mean generations born off Earth, new cultural norms, and unique challenges of maintaining mental health and social cohesion in isolated environments. Musk's vision encourages us to imagine these new social structures and prepare for the profound changes ahead. Technologically, space colonies will integrate with Musk's other longevity predictions. Genetic engineering might protect colonists from radiation-induced mutations. AI-driven medicine will provide personalized healthcare in remote settings. Neural interfaces could enhance cognitive function, critical for solving complex problems in space. Together, these innovations create a holistic approach to human longevity that spans Earth and beyond. Imagine a colony on Mars with habitats designed for optimal health, where residents receive gene therapies tailored to space conditions, use AI assistants to monitor their well-being, and maintain mental sharpness through neural interfaces. This interconnected system embodies Musk's vision of a future where living past 70 is not only possible but part of a new chapter in human evolution. As you contemplate this prediction, consider the broader meaning of space colonization for human life. How would leaving Earth change your perspective on aging, health, and existence? What challenges and opportunities would arise in building new societies off-world? Musk's prediction invites us to think boldly, merging technology, exploration, and humanity's deepest aspirations. It reminds us that the quest for longevity is not just a medical or scientific endeavor but a journey that connects us to the cosmos and to each other. This chapter expands the story of living past 70 beyond biology and technology into the realm of adventure, survival, and the human spirit's relentless drive to explore and endure. As the narrative unfolds, space colonies emerge as both a literal and metaphorical frontier, a place where the future of longevity is forged among the stars. Elon Musk's seventh and final prediction about living past 70 delves into the revolutionary possibilities of genetic engineering and regenerative medicine as the ultimate frontier in human longevity. Musk argues that while technology, AI, and space colonization offer transformative tools, the key to truly radical life extension lies in fundamentally altering the biological mechanisms of aging at the genetic and cellular levels. The science of aging has made tremendous strides in recent decades, revealing that aging is not simply an inevitable decline but a complex, multifaceted process driven by genetic, epigenetic, and environmental factors. Musk's vision anticipates a future where genetic interventions, stem cell therapies, and advanced regenerative medicine work synergistically to repair, replace, or rejuvenate aging tissues and organs, effectively reversing the aging clock and dramatically extending healthy human lifespan. At the heart of this prediction is the concept of addressing the root causes of aging, telomere shortening, mitochondrial dysfunction, cellular senescence, DNA damage, and protein misfolding, through targeted gene editing and regenerative techniques. Technologies like CRISPR-Cas9 have already demonstrated the ability to edit genes with unprecedented precision, raising the possibility of correcting mutations that contribute to age-related diseases such as cancer, Alzheimer's, and cardiovascular conditions. Musk envisions a future where such technologies are routinely applied not only to treat disease but to optimize the human genome for longevity, enhancing DNA repair mechanisms and resilience against environmental stressors. Regenerative medicine complements genetic engineering by using stem cells and bioengineered tissues to replace damaged organs and restore function. Imagine a world where failing hearts, deteriorating joints, or impaired lungs can be replaced with lab-grown, genetically matched tissues, eliminating the need for organ donors and immunosuppressive drugs. This ability to regenerate the body's essential systems could allow people to maintain physical vitality and health well into their 90s, 100s, and beyond. Scientific research supports this vision. Experiments on animals have shown that manipulating genes related to longevity can extend lifespan by significant margins. Some animals, like certain species of turtles and whales, naturally have mechanisms that protect them from age-related decline, and understanding these mechanisms could unlock similar benefits in humans. Furthermore, clinical trials involving stem cell therapies have shown promise in repairing cardiac tissue after heart attacks and regenerating skin, indicating that regenerative medicine's potential is rapidly approaching practical application. Emotionally, this prediction touches on deep human desires, to not just live longer but to maintain youthfulness, strength, and independence. The fear of physical and cognitive decline is a powerful motivator, and the possibility of reversing aging offers hope for a second youth or a prolonged prime. However, this also raises questions about the social and psychological impacts of extended lifespans. What does it mean for identity and life purpose if people can live far beyond current expectations? How will society manage resources, relationships, and generational dynamics when lifespans stretch dramatically? Ethical concerns loom large. The prospect of genetically editing humans to enhance longevity provokes debate about playing God, potential unintended consequences, and equitable access. Musk emphasizes the importance of responsible research, regulation, and public dialogue to ensure that genetic technologies are safe, ethical, and accessible to all, preventing the creation of a divided society where only the wealthy benefit from life extension. Personal stories of individuals participating in regenerative medicine trials or genetic therapies illustrate the hope and challenges of this prediction. Patients with degenerative diseases report improved quality of life, and researchers describe breakthroughs that were unimaginable just a decade ago. These narratives ground a futuristic vision in present-day realities, showing that radical life extension is not mere fantasy but an emerging scientific frontier. Economically, radical life extension could profoundly transform healthcare systems, retirement planning, and social services. Longer, healthier lives could mean extended careers, more time for personal development, and greater contributions to society. Yet this also requires rethinking pensions, employment laws, and education systems to accommodate new life stages. Musk's vision includes a holistic approach where society evolves alongside biological advances, fostering environments that support lifelong growth. This prediction interweaves with Musk's other ideas. Genetic enhancements could protect space colonists from radiation and the stresses of off-world living. Neural interfaces might monitor gene expression and cellular health in real time, allowing precise interventions. AI-driven medicine could analyze vast genetic data sets to optimize therapies continuously. Together, these innovations paint a future where aging is no longer a passive process but an actively managed, dynamic state. Visualize a future where a simple genetic test reveals your personalized aging risk profile, and a tailored gene therapy cocktail rejuvenates your cells, repairing years of damage. Imagine a world where organs are regenerated on demand, and wearable devices alert you to cellular changes before symptoms appear. This is the transformative promise of Musk's prediction, where science and technology converge to rewrite the biological limits of human life. Yet with this promise comes responsibility. The potential for misuse, unintended genetic consequences, and social disparities means that humanity must proceed carefully and thoughtfully. Musk's call for collaboration among scientists, ethicists, policymakers, and the public underscores the need for transparency, equity, and precaution in this brave new world. As you reflect on this final prediction, consider what radical life extension would mean for you personally. How would you live differently with many more healthy years? What risks and rewards do you see in rewriting our genetic code? Musk's vision challenges us to rethink aging not as an unavoidable decline but as a complex problem solvable by science and innovation. This chapter closes the circle on Musk's 7 shocking predictions, weaving together the technological, biological, and societal threads that form his roadmap to living past 70. From AI to neural interfaces, space colonies to gene editing, the future Musk imagines is one where human life is extended, enriched, and empowered by cutting-edge innovation. The journey is not without challenges, but the potential rewards, a longer, healthier, and more vibrant life, are profound. In the chapters to come, we will explore expert perspectives on these predictions, examine their scientific backing in detail, and reflect on the broader implications for society, ethics, and the human spirit. The story of living past 70 is not just about survival, it is about thriving in a rapidly changing world, embracing technology as a partner in our quest for longevity and meaning. Hit subscribe and leave a comment with where you're watching from. This story might just spark a new beginning. What's one thing that always pushes you forward, even when things get tough? Elon Musk's 7 shocking predictions about living past 70 might sound like futuristic fantasies, but they are grounded in serious scientific research and emerging technologies. In this chapter, we dive deeper into the science behind each prediction, gathering insights from leading experts in fields ranging from artificial intelligence and genetics to space medicine and neural engineering. Their perspectives not only validate Musk's vision but also shed light on the challenges and opportunities ahead for extending human life. Starting with Musk's first prediction, the rise of artificial intelligence and personalized medicine, Dr. Lee-Seng Gwyn, a pioneer in AI-driven healthcare at Stanford University, explains that AI's ability to analyze vast datasets quickly and accurately is revolutionizing how we diagnose and treat diseases. AI algorithms can detect subtle patterns in genetic and medical data that humans might miss, she says. This allows for earlier diagnosis of conditions like cancer or Alzheimer's, which is crucial for effective treatment and longevity. Personalized medicine, powered by AI, tailors therapies to an individual's unique biology, reducing side effects and improving outcomes. Dr. Nguyen stresses, however, that integrating AI into healthcare requires robust data privacy protections and ongoing collaboration between machines and clinicians. Moving to Musk's second prediction about gene editing and regenerative medicine, Dr. Miguel Alvarez, a geneticist at MIT, highlights how CRISPR technology has transformed genetic research in the past decade. We now have tools to precisely edit DNA, correcting mutations responsible for hereditary diseases, he explains. This is the foundation for therapies that could prevent age-related illnesses or even delay aging itself. Dr. Alvarez points out that while promising, gene editing is still in early clinical stages and requires careful ethical oversight to prevent unintended consequences. Regenerative medicine, involving stem cells and tissue engineering, offers complementary approaches. For example, lab-grown organs could eventually replace failing ones, extending healthy lifespan. Dr. Alvarez notes that scaling these technologies to safe, affordable treatments remains a significant hurdle. Regarding Musk's third prediction on AI-powered diagnostics and wearables, Dr. Emily Chen, a biomedical engineer specializing in sensor technology, discusses how devices like smartwatches and implantables continuously monitor vital signs and biochemical markers. These devices can detect early signs of illness or physiological stress, enabling proactive interventions, she says. Coupled with AI, they create a feedback loop that helps maintain optimal health. Dr. Chen foresees that future wearables will be even more integrated, non-invasive, and capable of monitoring molecular-level changes, offering real-time health management and personalized alerts. Privacy and data security remain key concerns as these technologies advance. On Musk's fourth prediction about neural interfaces, Dr. Raj Patel, a neuroscientist involved with brain-computer interface research, shares insights on how devices like Neuralink aim to bridge the brain and machines. We are learning to read and stimulate neural signals with increasing precision, Dr. Patel explains. This has huge potential for treating neurological disorders and enhancing cognition. He emphasizes that preserving cognitive function with age could be achieved through early detection of neural decline and targeted electrical stimulation or drug delivery via implanted devices. However, Dr. Patel warns that brain implants raise ethical and safety challenges, including risks of infection, privacy breaches, and the psychological impact of blending human and machine. When discussing Musk's fifth prediction, the role of space colonies in human longevity, Dr. Susan Reynolds, a space medicine specialist at NASA, underscores the health risks and adaptations needed for life beyond Earth. Radiation exposure, muscle atrophy, and psychological stress are major challenges for long-duration space missions, she explains. Developing countermeasures for these issues will not only protect astronauts but lead to advances in healthcare on Earth. Dr. Reynolds highlights how closed-loop life support systems, radiation shielding, and novel pharmaceuticals are in development to create safe, sustainable habitats on Mars or the Moon. She also notes the importance of addressing mental health through social support and virtual reality tools to combat isolation. Experts also weigh in on Musk's sixth prediction about AI-assisted longevity. Dr. Michael O'Connor, an AI ethicist, stresses the dual-edged nature of AI in healthcare and longevity. AI has enormous potential to extend life, but it also poses risks like algorithmic bias, unequal access, and loss of human touch in medicine, he says. We must balance innovation with ethical frameworks that ensure fairness and accountability. Dr. O'Connor advocates for transparent AI systems, inclusive datasets, and policies that promote equitable distribution of longevity technologies to avoid exacerbating social inequalities. Finally, reflecting on Musk's seventh prediction of radical genetic and regenerative therapies, Dr. Karen Liu, a bioethicist at Harvard Medical School, discusses the moral implications. The prospect of dramatically extending human life raises profound questions about identity, resource allocation, and intergenerational justice, she explains. Who decides who gets access? How do we maintain societal balance when lifespans diverge widely? Dr. Liu calls for robust public engagement and policy development to guide responsible use of these technologies, emphasizing that longevity should enhance quality of life, not just quantity. These expert insights collectively affirm that Musk's predictions are anchored in credible scientific advances but also highlight the complexity and interdisciplinary nature of the journey toward living past 70. They stress the need for collaboration among scientists, ethicists, policymakers, and the public to navigate technical, ethical, and social challenges. The path forward involves integrating AI, genetics, regenerative medicine, neural technology, and space exploration into a cohesive framework that supports healthy aging. Moreover, these experts highlight a common theme: longevity is not just about extending years but about enhancing health span, the period of life spent in good health, free from chronic disease and disability. The ultimate goal is to empower individuals to live longer, more vibrant, and fulfilling lives, contributing to society and personal growth. Musk's vision encapsulates this holistic approach, combining technological innovation with a deep understanding of human biology and social dynamics. As you absorb these expert perspectives, consider the broader implications. How do these technologies intersect with your values and hopes for aging? What societal changes do you anticipate as life extension becomes more attainable? Musk's predictions invite not only scientific curiosity but also ethical reflection and collective action. This chapter reinforces that living past 70 is a multidisciplinary challenge that requires innovation, responsibility, and empathy. It sets the stage for the concluding chapters where we explore the practical steps individuals and society can take to prepare for this future and the inspiring stories of those already benefiting from early forms of these technologies. Behind Elon Musk's bold predictions and the expert analyses lies the beating heart of the story, real people whose lives are touched by the quest to live past 70, not just in theory, but in practice. In this chapter, we explore the deeply human dimension of longevity, the hopes, struggles, breakthroughs, and everyday realities faced by those pushing the boundaries of aging. These stories reveal how Musk's futuristic vision intersects with lived experience, inspiring us with resilience, courage, and the promise of a new era in human health. Meet Sarah Thompson, a 68-year-old cancer survivor from Ohio, who credits personalized medicine and AI-powered diagnostics with giving her a second chance at life. Diagnosed with an aggressive form of breast cancer 5 years ago, Sarah's treatment plan was crafted using genomic sequencing and AI analysis to target her specific tumor mutations. "Without that technology, I don't know if I would be here today," she says. Sarah's story is a testament to Musk's first and third predictions, how AI and personalized medicine are already saving lives and improving health outcomes for aging populations. Her experience highlights the emotional roller coaster of facing mortality and the hope that science can transform despair into renewed vitality. Then there's Marcus Lee, a 45-year-old genetic therapy participant from California, who embodies the promise and challenges of Musk's second and seventh predictions about gene editing and regenerative medicine. Marcus suffers from a rare genetic disorder that causes muscle wasting. Enrolled in a pioneering CRISPR-based clinical trial, he has seen remarkable improvements in muscle strength and mobility. "It feels like I'm getting my life back," Marcus shares. Yet he also grapples with the uncertainty of new therapies and the ethical questions of altering his genetic code. His journey reflects the cutting-edge nature of these treatments and the courage required to pioneer uncharted territory. On the frontier of neural interfaces, Emma Rodriguez, a 52-year-old stroke survivor from Texas, has undergone experimental brain-computer interface therapy to regain motor function. "The technology feels like magic," Emma says, describing how a neural implant helped her relearn movements and communicate more effectively. Her story exemplifies Musk's fourth prediction and the emotional triumphs and struggles of integrating human and machine. Emma's resilience and optimism show how these innovations can restore independence and hope to those facing neurological challenges with aging. Space colonization's human dimension emerges through the story of astronaut Dr. Raj Patel, a veteran of extended missions aboard the International Space Station. Facing muscle loss, radiation exposure, and isolation, Dr. Patel has become a vocal advocate for space medicine research aimed at protecting future colonists. "Living on Mars won't be easy," he admits, "but the technologies we develop for space will revolutionize healthcare on Earth." His story embodies Musk's fifth prediction and the dual nature of space as both a harsh frontier and a laboratory for longevity solutions. Dr. Patel's insights remind us of the human cost and hope behind the push to become a multiplanetary species. Across these stories runs a common thread, the interplay of hope and uncertainty, progress and risk, human frailty and technological promise. The emotional impact is profound. These are not just stories of science but of lives transformed, fears confronted, and dreams rekindled. They remind us that living past 70 is as much about mindset and community as it is about medicine and machines. Family dynamics also shape these experiences. Sarah's daughter, Mia, became her caregiver and advocate, navigating the complex medical system and emerging technologies. Marcus's wife, Angela, wrestles with the ethical dimensions of their son potentially inheriting altered genes. Emma's support group connects patients and families facing neurological challenges, providing emotional sustenance and practical advice. These relationships illustrate the social fabric that sustains longevity efforts and underscore the importance of empathy and connection. Experts emphasize that storytelling is a powerful tool for demystifying advanced longevity technologies and fostering public engagement. Personal narratives humanize abstract concepts, building trust and understanding. They also highlight disparities in access and outcomes, urging policymakers and innovators to prioritize equity. Musk's vision depends not only on breakthroughs in labs but on stories like these reaching broad audiences and inspiring collective action. From an economic perspective, these human stories spotlight the need for accessible, affordable longevity solutions. While cutting-edge therapies offer hope, their high costs and limited availability pose barriers. Advocates call for policies that support insurance coverage, public funding, and incentives for innovation that benefit all socioeconomic groups. Musk's predictions challenge us to ensure that the future of longevity is inclusive and just. Looking ahead, ongoing clinical trials, technological advances, and social initiatives promise to expand the reach of these life-extending interventions. Early adopters like Sarah, Marcus, Emma, and Dr. Patel offer a glimpse of what's possible, but also underscore the journey ahead. Their stories encourage us to embrace the complexity of aging, balancing optimism with realism, and recognizing that longevity is a shared human endeavor. As you reflect on these stories, ask yourself, what does living past 70 mean to you personally? How do hope, struggle, and breakthrough shape your vision of aging? Musk's predictions come alive through these human experiences, reminding us that the future of longevity is not just scientific but deeply personal, connected to the essence of who we are. This chapter enriches the narrative by anchoring Musk's futuristic ideas in the lived reality of people facing aging today. It invites empathy, curiosity, and engagement, setting the stage for practical insights on preparing for the longevity revolution in the chapters to come. Elon Musk's 7 shocking predictions about living past 70 paint a future where technology and science radically transform aging, but what about today? How can you prepare now for a future that promises longer, healthier lives? This chapter explores practical steps individuals can take to align their lifestyles, mindset, and choices with the emerging longevity revolution, empowering you to be an active participant rather than a passive observer. Living past 70 isn't just about technology, it's also about habits, awareness, and proactive health management. First, prioritize your physical health. No matter how advanced medicine becomes, the foundation for longevity is a strong, resilient body. Regular exercise is crucial. Aim for a combination of aerobic activities, strength training, and flexibility exercises. Research shows that maintaining muscle mass and cardiovascular health reduces risks of chronic diseases and improves quality of life as you age. Elon Musk's vision of longer lifespans relies on people entering old age with robust physical reserves, so building those reserves now is essential. Even simple habits like walking daily, stretching, or light resistance training can make a big difference over time. Nutrition plays an equally important role. Focus on a balanced diet rich in whole foods, vegetables, fruits, lean proteins, healthy fats, and whole grains. Avoid excessive processed foods, sugar, and unhealthy fats, which contribute to inflammation and disease. Emerging research on intermittent fasting and calorie restriction suggests these may promote cellular repair and longevity by activating protective metabolic pathways. While these approaches are not for everyone, they represent the type of nutritional strategies that align with longevity science. Consider consulting a nutritionist to develop a personalized eating plan that supports your health goals. Mental and emotional health is often overlooked but is a cornerstone of longevity. Chronic stress, depression, and social isolation negatively impact immune function and accelerate aging. Musk's vision includes technologies like neural interfaces to support brain health, but you can cultivate resilience today through mindfulness, meditation, social connection, and hobbies that bring joy. Engaging your mind with continuous learning, puzzles, or creative activities also supports cognitive health. Building a strong support network of family and friends provides emotional sustenance and combats loneliness, a major risk factor for poor health outcomes. Next, embrace technology as a tool for proactive health management. Wearable devices that track heart rate, sleep quality, and activity levels can provide valuable feedback and motivate healthier behaviors. Mobile apps can remind you to take medications, hydrate, or practice relaxation techniques. As AI-driven diagnostics become more common, consider integrating regular health screenings that use advanced imaging or genetic testing to detect issues early. Staying informed about new health technologies prepares you to take advantage of breakthroughs as they become available. Genetic testing is an area of growing relevance. While Musk predicts gene editing therapies will revolutionize longevity, current genetic testing can provide insights into your inherited risks for diseases like cancer, heart disease, or Alzheimer's. Knowing your genetic profile allows for tailored preventive strategies, such as increased screening or lifestyle adjustments. However, it's important to approach genetic information carefully, ideally with genetic counseling, to avoid unnecessary anxiety or misinterpretation. Transparency and privacy regarding your genetic data are critical as you navigate this evolving field. Another key aspect is sleep. Quality sleep is fundamental for cellular repair, hormone regulation, and cognitive function. Chronic sleep deprivation accelerates aging and increases risks of numerous diseases. Aim for 7 to 9 hours of restful sleep per night by maintaining a consistent schedule, minimizing light and noise, and avoiding screens before bedtime. As Musk's prediction of neural interfaces advances, future technologies may monitor and enhance sleep cycles, but the basics remain vital today. Environmental factors also influence longevity. Reducing exposure to pollution, harmful chemicals, and excessive UV radiation protects your body from damage. Create a healthy living environment by improving air quality, using non-toxic cleaning products, and spending time in nature. These measures support Musk's vision of optimizing health through both technology and lifestyle. Financial and social planning are essential for a long, fulfilling life. Musk's predictions imply that people may live well beyond 70, potentially working longer or pursuing multiple careers. Preparing financially through savings, investments, and retirement planning ensures security and freedom in later years. Socially, cultivating diverse interests and relationships provides purpose and engagement. Consider volunteering, joining clubs, or learning new skills to build a vibrant social life that enriches your longevity. Ethical and psychological preparation is equally important. The prospect of radical life extension raises questions about identity, purpose, and societal roles. Reflect on what a longer life means to you, what goals you want to pursue, how relationships might evolve, and how to maintain mental flexibility in changing circumstances. Musk's vision challenges us to adapt not only biologically but psychologically to new realities of aging. Finally, engage with the broader community and advocate for equitable access to longevity technologies. Support policies and initiatives that promote public health, research funding, and fair distribution of medical innovations. Staying informed and involved ensures that the benefits of the longevity revolution extend beyond individuals to society as a whole. In summary, preparing for living past 70 involves a multifaceted approach, nurturing physical, mental, and emotional health, leveraging technology wisely, planning financially and socially, and embracing ethical reflection and community engagement. These steps create a foundation that complements Musk's technological predictions and positions you to thrive in a future where longevity is within reach. As you implement these strategies, remember that longevity is a journey, not a destination. Small, consistent actions compound over time, shaping your health trajectory. Musk's vision is ambitious and inspiring, but the power to live longer and better starts with the choices you make today. Elon Musk's predictions about living past 70 don't just affect individual lives, they promise to reshape society at its core. This chapter explores the profound social implications of extended lifespans and how they challenge traditional notions of aging, work, family, and community. Understanding these shifts is essential as we collectively prepare for a future where longevity transforms not only biology but also culture and social structures. Historically, aging has been associated with retirement, decline, and withdrawal from active roles in society. However, if people live healthier, longer lives, as Musk envisions, these assumptions will no longer hold true. Older adults may remain physically and mentally vigorous well into their 80s, 90s, and beyond, redefining what it means to be old. This redefinition affects expectations for careers, education, and social participation. Longer life means more time to explore multiple careers, develop new skills, and contribute to communities in meaningful ways. Lifelong learning will become not just desirable but necessary. The workplace will undergo significant transformation. Traditional retirement at 65 will become outdated, replaced by flexible career paths and phased retirements. Companies may need to rethink benefits, training, and accommodations to support multi-generational workforces. Musk's vision of extended lifespans raises questions about intergenerational equity, how to balance opportunities for both younger and older workers, and how to foster collaboration rather than competition between age groups. Policies that promote age diversity and lifelong employability will be crucial. Family dynamics will also evolve. With longer lives, people may have more generations alive simultaneously, changing caregiving roles and family responsibilities. Older adults may support younger relatives financially or emotionally for longer periods, but they may also expect support themselves later in life. This could strengthen family bonds but also introduce new stresses. Musk's space colonization prediction adds another layer. How do families maintain connections when members live in radically different environments, such as Earth and Mars? Technology will play a key role in bridging distances and preserving relationships. Social services and healthcare systems face enormous challenges and opportunities. As longevity increases, the demand for age-friendly infrastructure, chronic disease management, and mental health support will grow. Musk's emphasis on AI and regenerative medicine offers hope for easing these pressures through more efficient, personalized care. However, equitable access remains a critical issue. Without it, extended lifespans could widen social inequalities. Societies will need to invest in public health, preventive care, and social programs that support aging populations inclusively. Culturally, attitudes toward aging may shift dramatically. In many cultures, youth is prized and aging is stigmatized, but longer, healthier lives could foster greater respect and value for older adults. Intergenerational exchange of wisdom and experience might become more common and celebrated. Art, media, and education will play a role in reshaping narratives around aging to emphasize vitality, contribution, and continued growth rather than decline. Ethical considerations will intensify. Questions about resource allocation, environmental sustainability, and population growth will become more urgent as lifespans extend. Musk's vision of space colonization as a solution reflects one approach to managing these challenges, but terrestrial policies around consumption, equity, and innovation will be equally important. Societies will have to grapple with balancing individual longevity with collective well-being. Community design and urban planning will adapt to support aging populations with active lifestyles. Walkable neighborhoods, accessible transportation, and mixed-use developments that encourage social interaction will become priorities. Technology-enabled smart cities might incorporate health monitoring and emergency response systems tailored for older residents, blending Musk's technological predictions with practical urban needs. Religion and philosophy will also engage with the longevity revolution. Extended lifespans provoke questions about meaning, purpose, and spiritual growth over a potentially much longer timeline. How do belief systems evolve when death becomes less imminent? How do people find motivation and fulfillment in extended lives? These questions highlight the importance of psychological and existential preparation alongside physical health. Finally, the longevity revolution could inspire new forms of civic engagement and social activism. Older adults, empowered by better health and longer lives, may become influential advocates for social justice, environmental protection, and technological ethics. Musk's predictions invite us to envision a society where age is a source of strength and experience that drives positive change. As you consider these social impacts, reflect on your role in shaping the future. How might your community evolve as people live longer? What attitudes and structures need to change to support this new reality? Musk's vision challenges us not only to extend life but to enrich it collectively. This chapter underscores that longevity is not just a biological or technological issue but a profound social transformation. Embracing this transformation with foresight and inclusivity will be key to realizing the full potential of living past 70. Elon Musk's predictions about living past 70 open thrilling possibilities, but they also bring complex ethical dilemmas that society must confront. This chapter delves into the moral questions raised by radical life extension technologies, exploring issues of fairness, identity, access, and the broader consequences for humanity. As science pushes the boundaries of aging, ethical reflection is critical to ensure that longevity serves the common good rather than exacerbating inequalities or creating unforeseen harms. One of the most urgent concerns is equitable access. Advanced therapies such as gene editing, regenerative medicine, and AI-driven diagnostics could dramatically improve lifespan and health span, but they are likely to be expensive and initially limited to wealthy individuals or countries. Musk's vision challenges us to consider how to prevent a longevity divide, where only the privileged few benefit while marginalized populations are left behind. This inequality could deepen existing social and economic disparities, undermining social cohesion and justice. Policymakers, researchers, and corporations will need to prioritize affordability, distribution, and inclusion to avoid such outcomes. Another ethical question involves the societal impact of longer lives on population growth and resource consumption. If more people live healthier for longer, the demand for food, water, energy, and housing will increase, potentially stressing ecosystems and exacerbating climate change. Musk's advocacy for space colonization partly addresses this issue by proposing human expansion beyond Earth, but terrestrial solutions like sustainable development, environmental stewardship, and population management remain vital. The ethics of balancing individual longevity with planetary health will be a defining challenge of the century. The concept of identity and psychological continuity also comes into play. As technologies like neural interfaces and gene editing alter fundamental aspects of human biology, questions arise about what it means to remain oneself. If your brain's memories or personality are augmented or transferred through machines, or if your genes are edited to change traits, are you still the same person? How do we preserve individuality and dignity in a future of potential biological and cognitive transformation? These philosophical questions have implications for consent, autonomy, and legal rights. Additionally, the prospect of very long lives raises questions about the meaning and value of life stages. Traditional human life is structured around birth, growth, reproduction, aging, and death. Extending life significantly may require rethinking education, work, retirement, and family roles. Ethical concerns include how to ensure that people remain motivated and fulfilled over longer spans and how to prevent boredom, despair, or loss of purpose. Musk's predictions hint at a future where lifelong learning and reinvention become essential, but society must support individuals through these transitions. The use of gene editing, especially germline modifications passed to future generations, is particularly contentious. While correcting genetic diseases holds great promise, altering the human genome risks unintended consequences and ethical abuses, such as designer babies or eugenics. Robust regulatory frameworks, international cooperation, and public engagement are necessary to govern these technologies responsibly. Musk's involvement in advancing gene editing highlights both its potential and the need for cautious stewardship. Privacy and data security are further ethical concerns. AI diagnostics, neural interfaces, and wearable health devices generate vast amounts of sensitive personal data. Protecting this information from misuse, breaches, or discrimination is essential. Transparent policies, informed consent, and technological safeguards must accompany these innovations to respect individual rights. There are also ethical debates about the distribution of healthcare resources. As people live longer, medical systems may face choices about prioritizing treatments for aging-related conditions versus other health needs. Ethical frameworks like utilitarianism, justice, and respect for persons will guide these difficult decisions. Musk's vision encourages innovation to reduce healthcare burdens, but ethical dilemmas about allocation and prioritization will persist. Cultural and religious perspectives add complexity. Different traditions hold varying views on aging, death, and human enhancement. Some may embrace longevity technologies as a way to honor life, while others may see them as interfering with natural or divine order. Inclusive dialogue that respects diverse beliefs will be essential for socially acceptable policies and practices. Finally, the ethics of experimentation and clinical trials for longevity technologies deserve attention. Balancing the need for rapid progress with patient safety, informed consent, and transparency is vital. Musk's aggressive approach to innovation may accelerate breakthroughs, but it must be tempered by ethical oversight to prevent harm. In conclusion, the moral questions surrounding extended lifespans are as profound as the scientific ones. Musk's predictions compel us to engage deeply with these issues, fostering a culture of responsibility, equity, and respect. Ethical reflection is not a barrier to progress but a guide to ensure that the longevity revolution benefits all humanity and preserves what makes us human. Elon Musk's vision for living past 70 relies heavily on the transformative power of artificial intelligence, which is revolutionizing how we understand, diagnose, and treat aging. In this chapter, we explore how AI acts as a catalyst in longevity research and healthcare, accelerating discoveries and enabling personalized medicine at an unprecedented scale. AI is not just a tool but a partner in unlocking the secrets of extended healthspan and lifespan. The first major impact of AI is in data analysis. Aging is a complex biological process influenced by genetics, environment, lifestyle, and disease. Researchers generate massive datasets from genomics, proteomics, metabolomics, and clinical trials. Traditional analysis methods are overwhelmed by this volume and complexity. AI algorithms, particularly machine learning and deep learning, excel at identifying patterns and correlations in big data that humans cannot easily detect. This capability accelerates understanding of aging mechanisms, identifying biomarkers that predict health decline, and discovering new drug targets. Personalized medicine is another area transformed by AI. Instead of one-size-fits-all treatments, AI analyzes an individual's genetic profile, medical history, lifestyle, and environment to craft tailored interventions. This approach aligns with Musk's prediction that gene editing and regenerative medicine will be central to living longer. AI helps select the right therapies, optimize dosages, and monitor responses in real time, increasing efficacy and minimizing side effects. For example, AI-driven platforms can recommend lifestyle changes or supplements based on personal risk factors, empowering proactive health management. Drug discovery, traditionally a slow and expensive process, benefits greatly from AI. Algorithms can simulate molecular interactions, predict drug efficacy, and identify candidates for repurposing existing medications. This accelerates the pipeline from laboratory to clinical trials, enabling faster development of treatments targeting aging pathways. Musk's involvement in biotech innovation reflects this trend toward integrating AI into pharmaceutical research. AI also plays a crucial role in diagnostics. Advanced imaging analysis powered by AI detects early signs of diseases like cancer, Alzheimer's, or cardiovascular conditions, often before symptoms appear. Early detection is key to effective intervention and longevity. Wearable devices equipped with AI monitor vital signs continuously, alerting users and physicians to potential health issues. These technologies extend Musk's prediction about neural interfaces by integrating real-time health data with AI-driven decision support. Beyond the individual level, AI aids public health by modeling aging populations and predicting healthcare needs. This helps policymakers allocate resources, design preventive programs, and manage chronic diseases at scale. As more people live longer, AI-driven population health management becomes vital to sustainability. Ethically, AI introduces challenges such as algorithmic bias, data privacy, and the need for transparency. Musk and other leaders emphasize responsible AI development, ensuring these tools serve humanity equitably and safely. Explainable AI models that allow human oversight and validation are essential for trust in medical applications. Looking forward, AI could integrate with other emerging technologies Musk highlights, such as neural interfaces and gene editing, to create closed-loop systems where diagnostics, treatment, and monitoring are seamlessly connected. This synergy may enable dynamic, adaptive therapies that evolve with the patient's changing biology, maximizing longevity benefits. In summary, AI is a cornerstone of the longevity revolution, transforming research, healthcare, and public health. Musk's predictions underscore its central role in making extended, healthy lives a reality. Embracing AI's potential while addressing its challenges will be key to accelerating progress and ensuring ethical, inclusive advances. Elon Musk's vision of living past 70 heavily features neural interfaces, advanced technologies designed to connect the human brain directly with computers. These interfaces promise not only to treat neurological diseases but also to enhance cognitive function, preserve memory, and potentially slow or reverse mental decline associated with aging. This chapter dives into how neural interfaces could unlock a new frontier in mental longevity, transforming how we maintain and enhance brain health throughout extended lifespans. The brain is the most complex organ in the body, responsible for memory, reasoning, emotion, and identity. As people age, cognitive decline, dementia, and neurodegenerative diseases become major threats to quality of life. Musk's Neuralink project exemplifies efforts to develop minimally invasive brain-machine interfaces that can monitor, stimulate, and repair neural circuits. These interfaces use tiny electrodes implanted in the brain to communicate with external devices, offering possibilities for real-time brain data collection and therapeutic intervention. One promising application of neural interfaces is early detection and treatment of conditions like Alzheimer's and Parkinson's diseases. By continuously monitoring neural activity, these devices could identify subtle changes before symptoms emerge, enabling timely interventions that slow or halt progression. Stimulating specific brain regions electrically might also restore function or improve symptoms. This aligns with Musk's prediction that technology will extend not just lifespan but health span, the years lived with full cognitive capacity. Beyond treating disease, neural interfaces may enhance mental abilities. Cognitive augmentation could improve memory, learning speed, focus, and creativity. This raises exciting prospects for lifelong mental agility, allowing individuals to adapt and thrive in the rapidly changing world Musk envisions. Imagine uploading new skills directly to your brain or interacting seamlessly with AI assistants to boost problem solving. Such enhancements could redefine education, work, and social interaction, making extended lives intellectually fulfilling. Mental health benefits are another key aspect. Neural interfaces may help regulate mood disorders, anxiety, or PTSD by targeting dysfunctional brain circuits. Given the strong link between mental well-being and longevity, these technologies could significantly improve overall health outcomes. Continuous brain monitoring might also support personalized mental health care, adjusting treatments dynamically based on real-time data. However, neural interfaces also raise profound ethical and privacy concerns. Direct access to the brain risks misuse of sensitive thoughts, memories, or intentions. Safeguarding data security, ensuring informed consent, and preventing unauthorized manipulation are critical challenges. Musk and other leaders advocate developing robust ethical frameworks and regulations to protect users' autonomy and dignity. Technologically, neural interfaces face hurdles such as biocompatibility, long-term stability, and signal clarity. Implanting devices safely with minimal invasiveness is essential for widespread adoption. Advances in materials science, wireless communication, and AI-driven signal interpretation are helping overcome these barriers. Future iterations may be non-invasive or wearable, broadening accessibility. Integration with AI is a natural progression. AI can decode complex neural signals, translating brain activity into actionable commands or therapeutic responses. This symbiosis of human cognition and machine intelligence could create dynamic feedback loops, optimizing brain health and performance. Musk's vision includes not just restoring lost function but enhancing human potential, ushering in a new era of mental longevity. In conclusion, neural interfaces represent a groundbreaking pathway to extending cognitive health and vitality well beyond 70 years. They offer hope for preventing mental decline, enhancing abilities, and supporting emotional well-being in a future where longer lives are the norm. Embracing this technology thoughtfully will be crucial to harnessing its full potential while respecting fundamental human rights and values. Elon Musk's predictions about living past 70 take an extraordinary leap when he envisions space colonization as a key factor in extending human life. This chapter explores the radical idea that venturing beyond Earth is not just about exploration or survival, but also a pathway to redefining longevity. Musk's SpaceX ambitions intertwine with his vision for longer, healthier lives, suggesting that expanding humanity's presence in space could fundamentally change how we age and live. Earth's environment, with its limited resources, pollution, and vulnerability to catastrophes, poses challenges to sustaining large populations over extended periods. Musk argues that establishing colonies on Mars and other celestial bodies is essential to secure humanity's future. From a longevity perspective, space colonization could alleviate pressures related to overpopulation, resource depletion, and environmental degradation that threaten health and survival on Earth. By diversifying human habitats, we reduce existential risks and create new opportunities for life extension. Living in space or on other planets presents unique health challenges, such as exposure to radiation, microgravity effects on muscles and bones, and psychological stress from isolation. Musk's vision includes advanced technologies to mitigate these issues: artificial gravity habitats, radiation shielding, regenerative medicine, and AI-powered health monitoring. These innovations not only support space settlers but could also revolutionize healthcare on Earth, addressing aging-related deterioration. Space colonization may also accelerate biomedical research by providing novel environments for studying aging and disease. Microgravity and other extraterrestrial conditions could reveal insights into cellular and molecular processes, informing new therapies. Musk's predictions suggest a future where space-based laboratories complement Earth-bound research, speeding discoveries that enhance longevity. Psychologically, the prospect of living beyond Earth may inspire new motivations and meanings for extended life. The pioneering spirit required for space colonization aligns with Musk's broader message of continuous growth and challenge throughout long lifespans. Facing the unknown in distant worlds may foster resilience, creativity, and a profound sense of purpose, key factors for mental well-being and longevity. Ethical and social questions arise about who gets to participate in space colonization and how societies will govern off-world communities. Musk envisions democratizing access, but practical and economic barriers remain. Ensuring equitable opportunities and preventing new forms of inequality will be critical. Governance models must balance individual freedoms with collective responsibilities in these new frontiers. Technologically, space colonization is among the most complex endeavors ever attempted. It demands breakthroughs in propulsion, life support, habitat construction, and sustainability. Musk's SpaceX development of reusable rockets and plans for Mars missions are pioneering steps toward this goal. As these technologies mature, they may spill over into Earth applications, benefiting longevity science by improving resource efficiency, environmental control, and medical technologies. Culturally, space colonization may shift humanity's self-perception. No longer confined to a single planet, we become interplanetary beings with extended horizons. This broader perspective could influence values around longevity, community, and stewardship, encouraging long-term thinking and collective well-being. In summary, Elon Musk's prediction that space colonization will play a vital role in living past 70 expands the conversation from biological and technological solutions to include planetary and existential dimensions. The final frontier offers not just survival but the promise of new ways to live, thrive, and extend human life across the cosmos. Elon Musk's predictions about living past 70 also herald profound changes in the global economy and personal finances. As lifespans extend and health spans improve, the economic landscape will undergo a dramatic transformation, creating both opportunities and challenges. This chapter examines how extended longevity reshapes retirement planning, labor markets, healthcare costs, and economic growth, and what individuals and societies must do to prepare for the longevity economy Musk envisions. The traditional financial model is based on a life expectancy of roughly 70 to 80 years, with about 40 years of active work followed by 20 or more years of retirement. With Musk's prediction that people will regularly live well beyond 70 in good health, this model becomes obsolete. Individuals may need to plan for multiple careers and decades of financial activity well into their 90s or beyond. Retirement savings, pensions, and social security systems will face immense strain unless adapted to longer, more dynamic life trajectories. One critical change will be the rise of lifelong work or phased careers. Instead of a single linear path, people might cycle through periods of work, education, entrepreneurship, and leisure multiple times. This flexibility requires new financial planning strategies emphasizing continuous income generation, retraining, and savings management. Financial advisors and institutions must innovate products to meet these evolving needs, such as flexible retirement accounts, longevity insurance, and health investment funds. Healthcare costs are another major economic factor. While longer lives bring more years of productivity, they also risk higher cumulative healthcare spending if age-related diseases are not effectively prevented. Musk's emphasis on regenerative medicine, eye diagnostics, and neural interfaces offers hope for reducing chronic illness and disability, thus lowering long-term costs. Preventive care and personalized medicine enabled by these technologies could shift healthcare from expensive reactive treatments to cost-effective early interventions. At a macroeconomic level, a healthier, longer-living population could drive significant economic growth. More experienced workers contributing over extended careers can boost productivity and innovation. Additionally, new industries centered around longevity technologies, space colonization, and AI will emerge, creating jobs and investment opportunities. Musk's ventures are themselves catalysts in this longevity economy, pushing boundaries in biotech, space, and AI. However, economic inequality may worsen if access to longevity technologies is uneven. Wealthier individuals and nations might reap most benefits, leaving disadvantaged groups behind. This gap could fuel social unrest and require policy interventions such as subsidies, universal healthcare, and education reform to promote inclusive prosperity. Balancing innovation with fairness will be a key economic challenge. The insurance industry must also adapt. Life, health, and disability insurance products will need to reflect longer lifespans and changing risk profiles. Actuarial models will evolve to incorporate longevity-enhancing technologies and lifestyle factors. Musk's predictions imply a future where insurance supports not only risk mitigation but also health optimization. Financial markets may react to demographic shifts as well. Investors might prioritize companies involved in longevity science, AI, and space exploration. Pension funds and sovereign wealth funds will need to adjust asset allocations to account for longer payout horizons and changing economic dynamics. Musk's high-profile ventures often influence market trends and public sentiment, amplifying these effects. At the individual level, financial literacy and planning become more important than ever. People must understand the implications of extended lifespans for saving, investing, healthcare, and lifestyle choices. Education systems and employers can play a role in promoting lifelong financial education aligned with longevity realities. In conclusion, Elon Musk's predictions about living past 70 bring a new economic era where longevity is both an asset and a challenge. Preparing for this longevity economy requires innovation in financial products, healthcare delivery, labor policies, and social safety nets. Embracing these changes proactively can unlock unprecedented prosperity and well-being for individuals and societies alike. Elon Musk's predictions about living past 70 do not just affect biology and technology, they also herald profound shifts in human relationships and social dynamics. This chapter explores how extended lifespans may reshape family structures, friendships, romantic partnerships, and our understanding of identity and purpose. Living longer lives means rethinking social bonds across decades, which will challenge cultural norms and individual psychology alike. One of the most immediate effects of longer life is the extension of family relationships. Parents may live to see multiple generations of descendants grow, and grandparents might play active roles for far longer. Musk's vision of extended health span means elders could contribute wisdom and support well into advanced age, changing the nature of caregiving and intergenerational exchange. At the same time, the potential for longer marriages and partnerships raises questions about sustaining emotional intimacy and compatibility over many decades. Friendship dynamics are also likely to evolve. As careers, interests, and living situations shift across a longer lifespan, people may develop more varied and fluid social networks. Musk's emphasis on continuous learning and reinvention supports the idea of cultivating diverse connections throughout life. However, maintaining deep, meaningful friendships over extended time can be challenging, requiring intentional effort and new social skills. Romantic relationships face particularly complex challenges. The idea of "till death do us part" may be reinterpreted in a context where people live far beyond 70. Long-term commitments might require renegotiation, with possibilities for serial monogamy, open relationships, or redefined family units. This could reflect evolving cultural attitudes about love, loyalty, and personal growth. Musk's vision suggests that emotional resilience and adaptability will be crucial for thriving relationships in extended lives. The psychological impact of extended lifespans is multifaceted. On one hand, longer lives offer opportunities for growth, creativity, and fulfillment. On the other, they may bring risks of existential boredom, loneliness, or identity crises. Musk's ideas about mental augmentation and neural interfaces may help address cognitive challenges, but emotional well-being depends on social connection and purpose. Individuals may need to cultivate new coping strategies and support systems to navigate the extended lifespan. Society at large will also need to adapt. Social institutions like education, work, and retirement will evolve to support changing life patterns. Community organizations and social networks will become increasingly important to combat isolation. Musk's vision of an interconnected, technology-enabled society could facilitate new forms of social engagement, including virtual communities and AI companions that provide emotional support. Cultural narratives about aging will shift as well. The stigmas associated with old age may diminish if people remain active and vibrant into their 80s, 90s, and beyond. Musk's predictions encourage a mindset where aging is seen not as decline but as a stage of potential. This redefinition can foster respect and inclusion for older adults, enriching social cohesion. Identity over extended time spans presents unique psychological challenges. People may change careers, beliefs, lifestyles, and even bodies through gene editing or neural enhancements. Maintaining a coherent sense of self amid such transformations requires new frameworks of identity and memory. Musk's neural interface technologies might assist in preserving continuity, but philosophical questions about what it means to remain you will persist. In conclusion, the social and psychological dimensions of living past 70 are as important as the biological and technological ones. Elon Musk's predictions invite us to rethink relationships, community, and identity for a future where long, healthy lives become commonplace. Preparing for these changes with empathy, openness, and innovation will help individuals and societies flourish in the longevity era. As we arrive at the conclusion of Elon Musk's vision for living past 70, it's time to reflect on the journey from groundbreaking science to transformative technology, and ultimately, profound human change. This final chapter weaves together the threads explored throughout the story: biological innovation, neural interfaces, space colonization, economic shifts, and social evolution, offering a roadmap to embracing the longevity revolution with optimism and responsibility. Musk's 7 shocking predictions present a future once relegated to science fiction. Gene editing erasing hereditary diseases, AI accelerating medical breakthroughs, brain-machine interfaces preserving mental acuity, and space colonies extending human habitats beyond Earth. These technologies promise not only to extend lifespan but to enrich the quality of life, redefining what it means to age. Yet, with such promise comes complexity, ethical dilemmas, social challenges, and economic upheaval. Central to Musk's vision is the idea that longevity is not merely a personal endeavor but a collective mission. It requires collaboration across disciplines, industries, and governments. Scientific innovation must be coupled with ethical frameworks that ensure equitable access and protect individual rights. As Musk warns, the rapid pace of technological change demands vigilance to avoid unintended consequences and disparities. The story of living past 70 is also a story about human resilience and adaptability. Extended lives mean embracing continuous learning, reinventing ourselves across decades, and cultivating relationships that endure through change. Musk's ventures, from Tesla's relentless innovation to SpaceX's ambitious missions, embody this spirit of pushing boundaries and embracing uncertainty. Reflection invites us to consider what truly matters in a longer life. Beyond medical and technological marvels, it is love, family, purpose, and community that anchor human experience. Musk's journey highlights that technology can amplify these values but cannot replace them. Our humanity remains the foundation upon which the longevity revolution must build. Looking forward, the path to living past 70 will be uneven and filled with challenges. Not everyone will have immediate access to cutting-edge treatments, and societal adaptation will take time. Education, policy reform, and cultural shifts are essential to prepare individuals and communities for this new reality. Musk's predictions are a call to action, to innovate boldly while building inclusive systems that benefit all. The final, shocking punchline Musk offers is both inspiring and sobering. Living longer lives is within reach, but it demands that we take responsibility now, for our health, our environment, and each other. The choices we make today will shape the future of humanity's longevity. As the story closes, the question lingers: how will you embrace this new era? Will you invest in your health, support scientific progress, and nurture the relationships that make life meaningful? This story might just spark a new beginning. Hit subscribe and leave a comment with where you're watching from. What's one thing that always pushes you forward, even when things get tough? Remember, life is full of surprises, but love, innovation, and resilience will always lead the way. With the longevity revolution underway, we stand at the dawn of a new chapter in human history. Elon Musk's predictions challenge us to imagine and build a future where living past 70 is not just possible, but vibrant, fulfilling, and deeply human.